Hi everyone. So I am decided to create a homework for volumes being found from cross sections in Calculus 1. And this has been something I've always wanted to do is make better homeworks and something like this. It actually took me a long time because every single time I wanted a really good equation, I had to copy and save it as an image and then insert the image. That was a little rough, but I was excited. I learned how to use like this little stimulus over here. So I put a video I want them to watch, and then on the right of the homework, they have to answer in their own words about the video, and they use some real life examples of an apple, which was really fun to watch this video. Oops, I think I just clicked on that. Ah, okay, let me go back. Sorry about that. And so that was kind of fun. That was new for me to learn about. So then I start with a basic thing that they already know. What's the general formula for the area of a square? And here they can answer and get immediate feedback if they know that or not. And then what we're going to do is we're going to look at a general formula for a square now in terms of x. So when I have two different functions that are being graphed, and so x here is this top minus the bottom, and that's going to be filled in for the variable that they had. So then again, it's a multiple choice so they can see if they are on the right track or not. The next thing I do is I have them go to this website, and this is where I'm getting a lot of the fun stuff from. And I'm gonna have them right now just do the square, and they can change how many I want them to see and the range that they're gonna see it as. And so they're gonna see that as they get an infinite amount, like all of these are gonna become nice and smooth, and that's where we're gonna get into integration. But a lot of times you'll just see some cross sections that look more like this, as you are trying to find this whole volume going on of this crazy fun shape. So if you have ever seen the Kaufman Center of Performing Arts, that looks a lot like what they are finding. And I actually show them that picture when we first start. You're going to see even more when I get to the semicircles. Okay, so after that, then they actually have to go and solve the equation. I'm not going to make them type up all of their work. That's just a lot in math. So I'm going to let them take a picture and drop it into the canvas where I can see it. So then we move on and we do equilateral triangles and kind of move through that same process. So first they get what they already know for an equilateral triangle, back from geometry. And then we do that in terms of x. So we kind of take that first step. And then I have them go to that site again. But this time they're going to look with equilateral triangles. Let me get rid of the squares. And they can kind of play around to see the shapes and how it's a little bit different. So they're going to be getting a little bit different volumes as they go. And then I have them set up everything, like I said, where they actually solve the definite integral and take a picture where I can look at it. And then the last one I'm going to have them do, because these are the main three. Later, we're going to have more than just these three types of areas. But this one's usually the hardest is a semicircle, because now they have to know this equation in terms of the diameter, not the radius, because that whole side that we're going to be talking about is a diameter. And so they have to know that formula. And so then I just kind of snip at the one and we go in terms of x. And then here they go back to this site. And now we're going to look at the semicircles. And here, hopefully you're kind of seeing that this does look more like what you see at the Kaufman Center. It's kind of fun. And how far they're going to go out to do that. And so, but like I was saying, this whole length is a diameter, not just a radius. So we have to adapt our formula from what they've always known as, hey, pi r squared, but over 2 for a semicircle, but it's no longer using the r. We have to use the diameter. Okay, so after that, they do a basic integral over that picture. So then I level up a lot, which is I give them an AP question. So this is one from the AP exam. And so they have to go and find these points of intersection. They get to use their calculator. And then you can see that the two functions flip flop. So they got to also see that part. And they're going to make a video of doing the cross sections that are squares. Okay, so that was like the first one that we did. And so they're going to have to make a video of them describing every process that they have done here. Then we're going to have two peers watch the video. So they will make a copy of their peer review and send that to them. And lastly, they will say if they would have made any differences from watching their peer video, like getting that feedback and seeing if there were any changes that they would have made. So that is their homework for this volumes of a cross section. And I'm kind of excited about this. So I hope that they like it. I'm going to try it out this fourth quarter.